So hello everyone, welcome back to the channel, and you are watching Komal Taya. So guys, in the last video I talked about a very important concept according to examination point of view, that was Dirac delta function, and I discussed the theory behind it and how you'll solve the question. And in this video I'll take one example based on that concept, right? So that is one previous year question of CSIR chemistry only, right? So we'll be discussing about that, and we'll be seeing that how to proceed with question, how to solve the perturbation part or the first order energy correction if perturbed part is given in Dirac delta function, how Dirac delta will be governing the question to, so you can proceed ahead, right? So let's see what that question looks like, right? So this question is 19th question, as you can see on the screen, right? So this question says a particle is confined to move in 1D box of length L, right? So a particle is there and a box is there of length L, clear? So that can be 0 to L, right? If the system is perturbed by this, right? So the perturbation has been given in this form, that is delta x minus L by 2, right? So now you can see in question the perturbation has been given in terms of Dirac delta function. Can you see? Yeah, I hope that will be clear to you. So, and we have to find the first order energy correction to the ground state, right? And we have to find this thing, the energy correction in first order and first order energy correction in ground state. And you know the ground, we always write state over here, clear? And here we write this order, right? So the first order, it will be 1 only, and state. So since ground state for particle in 1D box, n is equal to 1 for ground state, right? So you must be knowing about it. So you will put over 1 over here, clear? And you need to find this, and these are the option, which is 2 by L, L by 2, and 1 by L, and 0. And you have to find out that what will be the energy correction. So let's see, I have the solution with me. So we'll be solving the question. So let's see. So the question is this, 0 to L length. So the perturbation has been given in this form. Particle in 1D box was there, right? And perturbation is in this form, that is delta H. So delta H would be equal to this delta and x minus L by 2, because this was given in the question, right? And we need to find the first order energy correction. So the first order energy correction, you know the basic formula is this, psi 1, because the state is 1, so you will write 1, and delta H, whatever the perturbation will be there, then psi 1 and dx and the limits. So the particle in 1D box, so one dimensional box is there and limits are 0 to L, so you will write limits from 0 to L. I hope this thing is clear to you. So let's see now, since perturbation is in this form, you can see the perturbation is in form delta form. So just simply put the values first. So okay, let's see the values. So it would be 0 to L, fine, and psi 1. So let me tell you the basic formula, and let me rub this. Wait, I'll do it on left hand side. I'm lacking of space now. Okay, anyway, just put over this thing that you know the wave function. The basic formula for this is, for 0 to L length box is root 2 by L sine n pi x by L, clear? So that is the basic wave function formula for particle in 1D box. And if I say n is equal to 1, which is given in the question, that is ground state, clear? So psi 1 will be, so this psi n, so this psi 1 will be root 2 by L sine n would be 1, so it would be pi x by L, clear? L or small l, whatever you want to use, clear? So basically I have put this value. So psi 1 is this, so I have put the value over here, which is root 2 by L sine pi x by L, clear? So I have put the value over here into what is next, that is perturbation. So perturbed part is given in this form. Can you see the Dirac delta form? So I'll put delta into x minus L by 2. As it is, I'm putting everything, clear? So into one more thing will be there, that is psi 1. So again psi 1 would be root 2 by L sine pi x by L, and simply I'm putting it over here, root 2 by L sine pi x by L, Clear? So what will be my next step? Think for 1 second or 2 seconds. You must be knowing how to do the question. Can you see how easy this question is? And if nobody, like if somebody does not know about this concept, he'll be missing on 4 marks like very easily, right? But this question is so easy that you can do it within 15 to 30 seconds when you will be having practice with that, obviously, right? So what is my next step? So that must be in your head, right? So if you have already watched my last lecture, so what I'll do, I'll put this form delta, and I'll put the whatever is apart from delta. So perturbed part is this, and I told you apart from delta you'll put everything equal to 0. So what apart from delta, what is there? That is x minus L by 2. So I will put x minus L by 2 is equal to 0. So that would be x is equal to L by 2. Clear? So now since I got the value, that is x is equal to L by 2, so what is my next step? So I'll try to put this value in the original equation. Clear? So let's see how to do that. First, let me just clear the mess which I always create. Yeah. So I'll put the values, but before that, before putting, what I'll do, I'll ignore the integration. The way I told you, I'll ignore the integration. Clear? So I have ignored the integration. Clear? So I have ignored. Now what I'll do, I'll ignore this part too. The perturbed part too, I'll ignore. Clear? So whatever is left apart from these things, I'll be putting the value of x in it. Clear? So the value of x is L by 2. Okay, x is L by 2. Remove integration, guys. The steps are remove integration. Fine. And second step is neglect delta part. Fine, neglect delta part, and third part is put the value of x. Clear? I'm writing over here. Clear? So these are just 3 steps which you have to follow. So just put the value of x. So now the value of x is L by 2. Clear? So just put the value over here. So it would be root 2 by L. Fine. And it is also root 2 by L. So when they'll be multiplied like this, so they will become 2 by L. Because root 2 by L is twice, right? It is twice. So it would be like this, 2 by L into what will happen? Now I will take this part, which is sin pi x by L. It is done, guys. I'm just ticking the things which I have done, like which I have counted. Fine. So let me just rub it first. So I'll be taking those things and I'll be ticking so that it becomes more clear to you. Anyway, I'm not taking this part, so I'm crossing it. Clear? So I have taken this part and this part, fine, which I have written over here, 2 by L. So now I'm taking this part, so which is sine into pi by L into x. So what is the value of x which I found out? That was L by 2 over here, and here also I have written, fine, so that would be L by 2. So instead of x, I'm putting the value, that would be L by 2 into what will happen. So this part I'll not count. Okay, so now what, this is already counted, so I'll take this part now. So that would be sine, okay, I have written sine into pi by L, okay, pi by L into what will be there, x. Fine, so the value of x I have already solved, that is L by 2. So I'll put the value of x, that is L by 2. So this L and L cancel out, L and L cancel out. So I'll be solving over here, guys. So it would become 2 by L into sine pi by 2, fine, into sine pi by 2. And you know sine 90, sine pi by 2, what is sine? Sine 0 is 0 and sine 90 is 1. So I'll put it like this, 1 into 1. So it would be 2 by L. And let's see which option it matches with. So it matches with A part, right? So yeah, so the option A is correct, and you can see how easy this question is, and you can just simply do this question in a very easy manner and very fast. You can solve it very fast, right? So I hope you like the lecture, and if you have any queries, please feel free to use the comment section and drop down your query. I have one Telegram group also, so you can join that too if you in case you have any doubt, or I just put my content over there. Right, I try to solve your queries there too. Clear, guys? And I hope you liked it. And in the next video also, I'm going to take one more example of Dirac delta function. Right, so that will be a little bit different from this one, and then we'll be done with first order perturbation. Then we'll be jumping over second order perturbation. Right, so that's it for this one.